Bolting a security camera to the outside of a building drills a literal hole through your digital firewall. By running a cable to the public street, you are leaving an active network port hanging on an exterior wall. Modern CCTV systems have evolved. They are fully functional Internet of Things computers, complete with operating systems, network interface controllers, and IP addresses. Because these devices sit entirely outside the physical security perimeter, they are highly exposed. An attacker doesn't need to pick a lock to reach them. They can simply unscrew a panel to access the physical wire, or intercept the local Wi-Fi signals the camera broadcasts to the router. Once an attacker breaches that single-edge device, they have a direct, unmonitored bridge into the building's internal systems. The heavy physical locks on the front door become entirely irrelevant. This vulnerability becomes a systemic risk in what engineers call a flat network. In a flat configuration, local installers take the easy route. They plug the IP cameras directly into a standard, unsegmented main router. That means the camera on the exterior brick wall shares the exact same digital space as the business's point-of-sale systems, the employee laptops, and private financial servers. When a hacker compromises the camera, they are already past the main internet firewall. They can now move laterally through the network, facing zero internal resistance because the router assumes all local traffic is trusted. In a flat network topology, the device purchased to secure the physical perimeter actually neutralizes the entire digital security posture of the business. To solve this, we have to look at the network's broadcast domain. A broadcast domain is simply a section of a computer network where all connected nodes can broadcast data frames directly to one another. Network segmentation is the engineering method used to break up these large, vulnerable broadcast domains into smaller, strictly controlled compartments. This diagram shows a standard flat network topology. Rather than running new physical cables, engineers use virtual local area networks, VLANs. Switches apply specific digital tags to data frames, creating invisible walls. If a camera is compromised, the attacker is trapped within that specific subnet. Structurally, VLANs transform a network from a single open room into a series of highly secure, locked vaults. However, simply checking a VLAN box in a router settings menu does not guarantee absolute security against advanced threats. Hackers use a technique called VLAN hopping. This is a sophisticated exploit where attackers manipulate those digital data tags to trick network switches into letting their traffic cross over the invisible walls. In a specific method called double tagging, an attacker hides a malicious destination tag underneath a legitimate one. The first switch reads the legitimate tag, strips it away, and forwards the data. The next switch then reads the hidden malicious tag and delivers the payload straight into the restricted network. Software-based logical barriers can be tricked if they are misconfigured. Truly secure systems require deeper structural separation when handling external access. Today, business owners expect to view their camera feeds remotely on their smartphones. Doing this inherently requires connecting the surveillance system to the public internet. This diagram shows the Demilitarized Zone. It is an isolated subnetwork engineered to safely house external-facing services. Notice the dual firewall mechanics. The camera server sends video outward to the internet, but a strict secondary firewall blocks any communication inward to your private network. A properly configured DMZ allows for the convenience of remote mobile access without sacrificing the integrity of the core internal network. For life-critical systems like aviation controls, industrial control sites, or highly classified government environments, even a DMZ presents an unacceptable level of risk. These environments use an air gap. This is a network architecture with zero physical or wireless connections to the outside internet. To move data in or out, a human being must physically carry a storage drive from one machine to another. When the stakes are absolute, total physical isolation remains the only mathematically guaranteed defense against remote digital intrusions. A professionally engineered security topology relies on multiple layers: isolated VLANs, a highly restricted DMZ, and hardened physical perimeters. This stands in direct contrast to the vulnerable, flat, plug-and-play models sold to consumers, which leave entire businesses exposed to anyone with a laptop and a Wi-Fi antenna. The physical camera hardware hanging on the wall is exactly the same in both scenarios. The true security lies entirely in the invisible network architecture supporting it. Protecting a physical property today strictly requires enterprise-grade cybersecurity engineering. Secure both your physical property and your digital footprint with third-eye security systems.